Hello there, Nareg is here. Today I'm going to talk about how to solve linear equations, which means first degree equations. Now, what do we mean by first degree equations? They are written as ax plus b, which is equal to 0. So, in order to solve an equation which is in this form, let's discuss first. We should say if a is different than 0, so the equation will remain first degree, and we can have ax is equal to minus b, so x is equal to minus b over a, so the solution or the root is equal to minus b over a. Alright, now what about the case where if a was equal to 0, in this case we have to check if b was equal to 0. In this case we can say that we have the infinite number of solutions, so s is equal to the whole real numbers. But if this is the second case, if b is different than 0, in this case we do not have any solution, so s is equal to the empty set. All right. So now, how do we solve first degree equations or linear equations where we have absolute values? I will take the general form and we're going to discuss it together. So the general form is when you have ax plus b is equal to cx plus d in absolute values. So what you should be doing next is to take, at first place you say ax plus b is equal to cx plus d, and you simply continue solving it, first degree linear equation. And then you have to solve one more time ax plus b is equal to minus cx minus d. So in this case, we can write it's minus cx plus d if you want. So you will have to rearrange it and then you will have to solve it. So this is how you solve a linear equation with an absolute value. Now, in case you had a polynomial which wasn't first degree, or it was second or third degree, what you should be doing, so in case you had a certain function or a polynomial which was higher than first degree, you should be factorizing. So you need to factorize. Once you factorize, you will have a product of first degree equations. Okay, all right. If your function or the polynomial, your function, let's say, was a rational one, let's say it was ax over bx, in this case, in order to solve this function, of course, you should talk about bx different than 0. That's the first condition. You should have bx different than 0, and then you simply say ax is equal to 0. Now ax could be first degree, you can solve it easily. Now if it was second degree, you need to factorize and etc. You have to go through the steps that we already mentioned above. Now I'm going to take some examples related to each part. Each part that we discuss, I'm going to take an example and we're going to solve them together. So let's start by the first one. What about this equation? So we have 3x minus 4 over 3 minus x over 12 is equal to x minus 1 over 4 minus 1 minus x over 6. Now, in order to solve This equation, of course, it's a polynomial. It's a linear equation of first degree. You do not have any rational form. It's a linear reduced form. So in this case, I will choose a common denominator. Let's say it was 12. It's going to be 12. So 12. In this case, I will have 12x minus 16 minus x is equal to, again, 12. So 3x minus 3, and then minus 2 plus 2x. All right. Since the denominator is 12, it's a real number, I can cancel out this the denominator, which is 12. And then I will have to rearrange my equation. So I will have 12x minus x minus 3x minus 2x is equal to minus 3 minus 2 plus 16. So one more time, we will have minus 6x is equal to 11. So x is equal to 11 over 6. So this is the root or the solution of your equation. So you can write down s is equal to 11 over 6. All right. Let's take another example. Let's take another example. Let's say we had an equation which was like this: 6x minus 7 to the power of 2 is equal to 2x minus 7 to the power of 2. As you can see, this equation will, in case I will expand it, it will be from the second degree. So you have 6x minus 7 to the power of 2. So it will be second degree. So in order to avoid having second degree and then to factorize, you simply check this form, which should remind you of a squared minus b squared. So once you write it down as 6x minus 7 squared minus 2x minus 7 squared is equal to 0, you will have the form which is a squared minus b squared. So a squared minus b squared, you can easily factorize it as a minus b, a plus b. So I can say it will be 6x minus 7 minus 2x plus 7 times the second factor, 6x minus 7 plus 2x minus 7 is equal to 0. As you can see, right now I have a product of factors, and each factor is first degree, it's linear. So the first one, I will have 4x times 8x minus 14 is equal to 0. A product of factors is equal to 0 if each factor is 0. So 4x is equal to 0, or 8x minus 14 is equal to 0. You will have x is equal to 0. This is the first root. Or x is equal to 14 over 8. You can simplify by reduce by 2. You will have 7 over 4. So this is the second root. So this was a case where we had to factorize because our equation wasn't first degree. Let's take another example. What about this equation? 16x squared minus 56x plus 49 is equal to 0. So in this case, you will have to say that it's the expansion of a binomial of a squared minus 2ab plus b squared. So I can simply say the second degree can be written as 4x minus 7 to the power of 2 which is equal to 0. So this reminds me of a squared minus 2ab plus b squared. So 4x minus 7 is equal to 0. 4x is equal to 7. X is equal to 7 over 4. And this is how you get your root 7 over 4. So from second degree, I was able to find its linear form. I factorized it, and then I was able to find the root or the solution. Let's take a new example. What about an equation which is simple like this? 2x plus 1 is equal to 2x. As you can see, you will have 2x minus 2x is equal to minus 1, so it will be 0x is equal to minus 1. In this case, you say the solution is the empty set. 0 could not be equal to minus 1. Now, what about this equation? X minus 7 in absolute values is equal to 2. So you should pay attention. You will have to say x minus 7 is equal to 2, or minus x minus 7 is equal to 2. So x is equal to 9, or minus x plus 7 is equal to 2. X is equal to, in this case, we will have 5. All right, and of course you can verify. In case you want to verify, 9 minus 7 is 2. In absolute values, it will stay 2. And 5 minus 7, it's minus 2 in absolute values, which will give you again 2. Now, what about this new example? Let's say we had the absolute values of 2x minus 3 plus 1 is equal to 0. You have to write down the absolute value. 2x minus 3 is equal to minus 1. Once you think about it, an absolute value could not be negative, so you simply say the solution is the empty set. There are no values of x for which you will obtain the absolute value of 2x minus 3 as minus 1. Let's take a new one, another example. 2x minus 1 in absolute values is equal to x plus 1 in absolute values. So the first one, you should say 2x minus 1 is equal to x plus 1, or 2x minus 1 is equal to minus x plus 1. So you will have x is equal to 2, and in this case you will have 2x minus 1 is equal to minus x minus 1. So 3x is equal to 0, x is equal to 0. And of course you can verify these roots or solutions. All right. Now let's take an example where we have a rational form. So in case it was x plus 3 over x minus 3 minus x minus 3 over x plus 3 is equal to 0. So you will have to choose a common denominator, which is x minus 3, x plus 3. So you will have x plus 3 to the power of 2 minus x minus 3 to the power of 2, which is equal to 0. Now the numerator, it's a squared minus b squared, so I can simply say it will be x plus 3 minus x plus 3 times x plus 3 plus x minus 3 over x minus 3 times x plus 3, of course, is equal to 0. I will have to rearrange it, so it will be 6 times 2x over x minus 3 times x plus 3 is equal to 0. Now, I should be talking about the condition that x minus 3 should be different than 0, x different than 3. Similarly, x plus 3 should be different than 0, x different than minus 3 in order for this fraction to exist. And then in order to solve it, you will have to say 12x, which is the numerator, is equal to 0. So x is equal to 0. Whenever x is equal to 0, you will have, in this case, a root. You will be able to solve this equation. All right. Now, what about another example? Again, I'm going to take a fraction, x to the power of 4 minus 81 over x plus 3 is equal to 0. So what I need to do is to factorize. It's 4th degree, the numerator is 4th degree, so I should say it's x squared minus 9 times x squared plus 9, a squared minus b squared over x plus 3 is equal to 0. And then once again x minus 3 times x plus 3 times x squared plus 9 over x plus 3 is equal to 0. Right now I can solve it. It's easy to solve it. You will have to say the first condition is to have x plus 3 different than 0, which means x different than minus 3, since your denominator is x plus 3. And then you will have to say the numerator x minus 3 is equal to 0, so x is equal to 3. Of course, you cannot take x is equal to minus 3. And for the third part, which is x squared plus 9, it will remain strictly positive, since x squared is positive or 0 plus 9, so it will be strictly positive. So this actually fraction has one root, which is x is equal to 3. All right. Let's take another example. What about the square root of x plus 4 is equal to 2 minus x. So whenever you have a square root, you should take the whole part to the power of 2. So I should write down square root of x plus 4 to the power of 2 is equal to 2 minus x to the power of 2. So it will be x plus 4 is equal to 4 plus x squared minus 4x. I will have, in this case, 0 is equal to x squared minus 5x. So x as a common factor, x minus 5 is equal to 0. X is equal to 0 or x is equal to 5. These are the two roots. Now, these two roots, you should verify them. You should verify. Let's say for x is equal to 0, square root of 0 plus 4 is the square root of 4, and 2 minus 0 is equal to 2. So in this case, x is equal to 0, it's acceptable. What about the second root? The square root of 5 plus 9, 5 plus 4 is the square root of 9, which is 3. And what about 2 minus 5 is actually minus 3. So x is equal to 5. You can say it's not an acceptable value. All right. What about one last example? And you will have, again, a square root of x squared plus 3x plus 6 is equal to the absolute value of x. One more time, I need to take the whole radical and take it to the power of 2. So it will be the square root of x squared plus 3x plus 6 to the power of 2 is equal to the absolute value of x to the power of 2. So you will have x squared plus 3x plus 6 is equal to x squared. X squared, they will cancel out. 3x is equal to minus 6. X is equal to minus 2. And this is how you get your answer. Alright, so this was a video related to linear equation, first degree equation, how to solve them. We discussed about the reduced form ax plus b is equal to 0. We took some examples with absolute value, with radicals, even some polynomials of higher degrees where we had to factorize and obtain a product of equations from first degree. And even we discussed about a certain fraction where you have ax over bx, and you should of course talk about the denominator different than 0, and you simply say the numerator is equal to 0 in order to solve this fraction. That's all for this video. Why don't you subscribe to my channel? You'll be notified whenever I upload new videos. And I can also share with you my Instagram and Facebook account in case you want to contact me, or you can simply leave a comment below. That's all for this time, and see you next time.